Hey there, welcome. If you've ever felt like algebra has its own secret language, you are definitely in the right place. Today, we're going to crack the code on quadratic expressions, and I promise by the end of this, you'll not only get them, you'll actually be able to use them with confidence.
I mean, it really can feel that way, can't it? You've got all these symbols, these new terms, all these rules. But, just like any language, once you get the hang of the grammar, you can start speaking it fluently.
And that is exactly our goal today. We are going to learn the language of quadratic. We'll break down how to read them, how to simplify them, and how to combine them. So, you ready? Let's dive in.
So here's our game plan. We're going to start with the absolute basics. Then we'll get into the core skills, simplifying, adding and subtracting, and expanding. And then at the end, we'll wrap it all up with the key things you really need to remember.
Okay, first things first. What in the world makes an expression quadratic? Let's get a really clear definition, because trust me, once you can spot one, you'll start seeing them everywhere, from the arc of a basketball shot to the curve of a satellite dish.
The clue is hiding right there in the name. Quad comes from the Latin word for square. So, a quadratic expression is really just any expression where the highest power of the variable is 2. That little squared term, that x squared, that's the signature move of a quadratic. It's the whole show.
All right, let's get our hands dirty with our first skill. Now, simplifying might look complicated, but it's really just about tidying up. Seriously, think of it like sorting laundry. You put all the socks in one pile, all the t-shirts in another before you do anything else. It's the same idea.
And it really just boils down to this super simple 3-step process. First, you hunt for the like terms. Get all the p squareds together, all the regular p's, and all the plain numbers. Then, you just kind of shuffle everything around to get those matching terms next to each other. And finally, you just combine them. That's it. It's a method that works every single time.
Okay, theory is one thing, but let's actually see this thing in action. We're going to walk through one together. So take a good look at the expression up on your screen.
So, what we have is 4p squared minus 3 minus 2p minus 3p squared minus p. Okay, a bit of a jumble. The first most important step is just to reorganize. We've spotted our like terms, the 2p squared terms and the 2p terms, and we've just herded them together. See? The constant, that lonely minus 3, just kind of hangs out at the end for now.
And now for the satisfying part. We combine. For the p squares, we have 4 minus 3, which just leaves us with 1p squared. For the p's, we have negative 2p minus another p, so that's negative 3p, and the negative 3, well, it just stays as it is. And there you have it. Look at that, our clean, simplified answer. Much better.
Okay, you saw how I did it. But honestly, the best way to really get this stuff to stick is to try it yourself. So let's do a quick practice run.
Here we go. Now notice that all three of these guys are like terms. They all have an x squared. So go ahead and pause this for a second, work it out, and then just hit play when you think you've got the answer.
All right, ready? Let's see how you did. The answer is negative 4x squared. You just combine the numbers out front. 2 minus 9 is negative 7, and then adding 3 to that gets you to negative 4. If you got that, awesome job. You're totally getting the hang of this.
Okay, time to level up a little bit. What happens when our quadratic expressions come wrapped up in these little packages? Brackets. Well, this is where adding and subtracting comes into play.
The method is pretty much the same, but there's one critical extra step that you absolutely cannot forget. When you are subtracting, that little minus sign outside the second bracket, it's like a magic wand that flips the sign of every single term inside. This is hands down the #1 trap people fall into, so let's look at it real close. So let's put that rule to the test with a subtraction problem. This is where that sign flipping rule goes from being a neat little trick to being absolutely essential to getting the right answer.
Okay, check this out. Our problem is negative 3x squared plus 2x plus 1 minus negative 4x squared plus 3x minus 2. Now we drop the brackets, and this is where the magic happens. Look at that second expression. The negative 4x squared, boom, is positive. The positive 3x, now it's negative. And the negative 2, it's positive. Every single sign got flipped because of that minus sign out front.
From here on out, it's just the same process we just learned. It's familiar territory. We group our like terms, combine them, and we're done. So negative 3x squared plus 4x squared gives us x squared. Then 2x minus 3x is negative x. And finally, 1 plus 2 is 3. And that's our final answer.
All right, you're doing great. Time for our final skill of the day, expansion. This is what you do when you need to multiply two expressions in brackets together. And it all comes down to one really important rule.
And that rule is called the distributive law. Now I know, it sounds a little fancy, but the idea is actually super simple. Everything in the first bracket has to get multiplied by everything in the second bracket. It's like a dance party. Everyone has to dance with everyone from the other group. No term gets left behind.
Let's see how this works with p minus 4 times 2p plus 9. First, we take the p from the first bracket and multiply it by that entire second bracket. So p times 2p plus 9 gives us 2p squared plus 9p. Okay, part 1 is done. Then we take the second term, that negative 4, and we do the exact same thing. We multiply it by the whole second bracket. That gives us negative 8p minus 36.
And now for the final step. We just take those two results we just got, smush them together, and simplify. We've got like terms right there in the middle, right? Positive 9p minus 8p, that's just a single p. So our final, fully expanded answer is 2p squared plus p minus 36.
So, let's just quickly recap the big ideas from today. First, simplifying is all about collecting those light terms. Second, and this is the big one, when you're subtracting, you have to remember to flip every single sign in that second bracket. Don't fall into that trap. And third, when you expand, just make sure every term multiplies every other term.
You know, these aren't just some abstract rules for a math class. These are fundamental tools. You now know how to handle the basic building blocks of algebra, the very same ones used in everything from physics to finance. So the only question left is, what are you going to build with them?